Good morning, students. Today we are going to discuss on operating system. So, in the second year, second semester, you'll be having a operating system subject, which is very important for the competitive exams and also in the placements, where they will be concentrating the most of the interview questions from the operating system. So, myself, Dr. Shirisha, Associate Professor from CSC Department, will be discussing about the operating system overview today. So, what we are going to discuss in this subject or in this course? If you see, the course code of the subject will be the A3CS12 in the R22 syllabus in the MLR Institute of Technology, and the course outcomes will be how the student and what the student will be gaining the knowledge based on the subject operating system. So, if you see, at the end of the course, students will be able to analyze different structures. So, here the different structures will be of operating system structures. So, what are the different operating systems are there, like Windows operating system, initially MS-DOS, then Linux operating system, Unix operating system. So, such operating systems will be varying based on their structures. So, what are those structures we'll be seeing, and the services of the operating system. In the first unit, we'll be dividing the entire first unit into the two different parts. So, one will be the overview and the other will be the structure. So, in the overview and also in the structure, we'll be discussing various scenarios of how operating system can be evaluated or how operating system can be understood. Okay, so services also, what are the services that OS will provide so that how it can manage different processes or different processors and also different management of the resources, etc. So that it can analyze based on few constraints. And the second outcome will be analyze various algorithms used for OS services with respect to defined or chosen criteria. So yes, definitely in operating system we'll be having different criteria like process management and memory management, then page replacement algorithms and memory management, IO management, so device management. So in these scenarios, to manage such things, we have to implement few algorithms. So what are those algorithms will be varying based upon the scenarios and also based upon the case studies or based upon the environment or the resources that you're going to use and different constraints, time constraints, resource constraints, process constraints, and user constraints and the number of users that are being using. So based on these different constraints, we'll be implementing different process scheduling algorithms and etc., disk scheduling algorithms, etc. So that we will be going to discuss in the next unit, second unit. So that will be your second outcome for analyzing various algorithms. Then coming to the third one, solve the resource allocation and sharing problems. So what resources are nothing but how you're going to use your hardware, how you're going to use your software, and also different hardware devices, not only the processor like printers or the resources that are shared, and how you're going to use and manage the data. So that is resource allocation, and what are the problems and how the operating system is providing solutions. We'll be discussing in the third unit. Then especially the deadlocks we'll be discussing. And the coming to the fourth one, assess different methods to solve OS problems. So we have different file management, memory management, where we can discuss them in the fourth unit. And there are different methods like first fit, best fit, how you're going to manage the memory, where you have free spaces and where there is a contiguous memory allocation, and how you're going to manage them based on different algorithms. Then coming to the fifth criteria or fifth course outcome is analyze the memory management approaches of the operating system, and this also concentrates on different algorithms like how you're going to implement linked list, hash tables, etc. Different page replacement algorithms where you can manage devices, so the device management will also come into the picture. So these are the few areas where we'll cover in the operating system. So going through, We are about to start our first unit, which is covering the operating system overview in the first part and operating system structures in the second part. Coming to operating system overview, you have to know what is operating system. So, this is just introduction. Then operating system operation. So, in how many operations are there to perform by the OS. Then these are different topics which we just intro here, and we'll see in depth along with the algorithms how you are going to manage the processes, how you are going to manage the memory management, how you are going to manage storage management and device management, etc. So these three, just the introduction part, we are going to discuss in the first unit, like what is process management, what is memory management, and what is the storage management. Such things first you have to understand. Then we have to go deeply to understand how the algorithms are going to be implemented. Then finally we'll see protection and security. So once you are using the operating system, if it has failed to give you the protection and also the security, then operating system fails, all your data will get failed. So there, how much importance is there to know the algorithms in these perspectives, like process management, memory management, storage management. In the same in the other perspective, you have to give the protection and security. And finally, distributed systems in the first part, how the data is being distributed, where you will see how the data is being shared among using the shared resources, and how the data is maintained centrally, and therefore when it is distributed, how the protection and security is provided in such case. So all this we are going to discuss in the first part. Coming to the second part, the structures, along with the structures, like how the layer, the structure, or the sequential structure. So like that, how you're going to see the operating system structures, followed by the services which each operating system is going to provide, and also the system calls. System calls, how the data is being managed, can be retrieved from the OS, can be stored in the OS, how it can be loaded, how it can be fetched. So all these can be managed by using the system calls, where system calls are nothing but the functions which you are going to implement in the operating system. Then system programs. So you have two different types of programs, where you call them as the system programs or the application programs. So we'll be discussing the differences between them, and what are the system programs, how they have to get managed, can be discussed. Then, as I told you, operating system structures. So all these are the part of that structure. And finally, operating system generations. If you see different generations of OS, initially the OS was different. The structure of the OS was different. Later on, year to year, when generations are passing, the structure of an OS is being improved, and whatever the drawbacks we have in the previous structures is being improved, and today we are in using the Windows 11 and Mac operating systems, which is again giving different versions of updates. So such things we will be understanding with the help of this first unit. So we start with operating system overview. And coming to the overview, first you have to understand the OS acts as a bridge between user applications and the system hardware. So you will be having a hardware, and you will be having a user who is using this operating system with the help of some say processor. Okay, how to process the data, and using this processor. So all this connection, this interaction is happening only because of OS. If you don't have OS in your system, then the user cannot operate this, where you can apply your system applications, or the applications softwares, or the system softwares that you are going to use for various purposes. And it does not perform a specific task, but creates an environment for applications to function. So how, if you wanted to use any software, so you need an operating system, then only you could see the GUI interface, and then you can implement the software applications, or whatever the applications you are using. And what are the operations of an OS? So coming to operations, we can discuss, there are two different operations like user mode and kernel mode that we'll be discussing shortly. And once the user perspective and kernel will be the heart of the operating system, where the operating system can send your data to the user and also take the data from the user and store it, load it, whatever. So you can do it only with the help of various operations. So to do various operations, basically it should support, first thing is the process management. So it handles the process execution, scheduling and multitasking. So suppose if you wanted to do three different jobs, so which job you're going to first? You're going to execute first. Or when if you want to execute, what are the resources that are needed? How the process can be executed? So to know all this, we'll be knowing in this process management, which is your second unit. As I told you, each and every part of this will be operation, will be each unit in your operating system. We have 5 units, out of which the first unit will be a general, whatever we discussed so far, and second unit will be the process management, and third unit will be the memory management, and fourth unit will be the device management, fifth unit will be the file management. So in such a way it has been organized. So how the process management is handling the process execution, that is nothing but the process management. So we have different scheduling. Scheduling is nothing but we have different algorithms to implement, where we call them as FCFS and SJF, and there are two different types and later we'll be discussing. And we have priority and we have round robin. These are the primarily used algorithms in the process scheduling. But what we do is, we'll be also having a multi-level queuing scheduling and multi-level feedback queue scheduling to work on this. Okay, so that we'll be seeing in the second unit. So coming to memory management, so you have to execute the process. You know how to execute the process and which scheduling algorithm to implement. But how to manage the memory? If you have the memory, then only you can take the photos or you can store it. A basic example that I am telling you, if you take a mobile phone, if your memory is full, if you open the camera and take a picture, will it be allowing you? No, because there is no memory, lack of memory. So it should have a memory management so that it allocates the processes within the memory and it stores it and it tracks it, how the data is being stored and to which extent it is being stored, how many duplications you have, how to manage them, whether data is lost, when it is lost. So log operations. So this is nothing but all this is tracking. Deallocates memory. If suppose if you have a process and you completed the job completely, it is no more required to store the data. So you can just remove it. So removing is nothing but the deallocating the memory from the process, so that your memory will get freed, and all the memory which has been freed, they call it as a free space management, where you can manage that sort of memory space. So that is a memory management we'll be discussing. Coming to third one, device management. It manages the communication between the hardware devices and the software devices via device drivers. So suppose if you have a printer, if you directly connect it to your browser, will you able to take the print? No. So you should have a device driver, install it, so that your printer should be compatible with the OS. If there is a compatibility and the device drivers are installed, then only you can use it. Like that, whatever the devices you're using, you should know how to use it and what are all the different applications or the softwares that are required for using them. That is about the device management. Next is the file management. File. So what is a file? Organizing the data. So if you wanted to store any data, you will be saving in the form of files. So how to organize it? You will be having hundreds and hundreds of files, then you have to organize it. Then you cannot load until and unless you know its location. So you have to organize. How we organize our house with or your bookshelf with a set of books, then in the same way we'll be organizing our files also. and it stores the data and you can retrieve the data whenever you are required when you are storing the data in the form of files. So file structure may be varying. It may be in the format of MPEG, it may be in the format of JPEG, it may be in the form of MP3 or MP4. So whatever be the type of the data should be stored first. So that we are calling it as a file. And protects the data in the file. So how do you protect the data? So when you are typing something, say if you are opening any file and you are typing something, you have created some data that if you are not storing it, then your data will get lost. Whenever there is some lack of protection or security to your operating system, then in such cases also your system may get failed, so that the data will be lost. So that is one scenario where you have to take care. Then, so you have operating system operations. So what are the operations that you can do is, you can do the process management, 2 memory management, device management, file management, and OS can do all these. Okay. So process management. So we'll see individually what are they. Okay. So deeply. So as I told you in the process management, so operating system processes, it manages the processes by assigning the processor to a process at a time, known as process scheduling. If you have 10 jobs, the processor can allow one job to execute and it can free up after its execution and give the chance to the second process. So like that, if you wanted to do multitasking or multi-programming, a processor should be compatible in such a way all the processes that are being in the queued, so that has to be into the execution, where we call it as a multi-programming or multitasking. So all such should be capable of doing by the operating system, that which we are calling it as a process management. So scheduling algorithm are used in this process management, where we could call FCFS, SGI, priority, round robin. As I told you, all these are the important scheduling algorithms. Deeply we'll discuss what are these algorithms, how to use them, and what are the case studies of these algorithms. And coming to scheduling queues in the process management, we have 3 different types of queues. So 1, 2, 3. One is a job queue. Job queue is nothing but what are the processes that are holding to entering into the system, that is to enter into your processor. The processor has to be allocated to the process, then only it can execute. The resource should be needed for any process to complete its execution. So to do that, we need a job queue. Then ready queue stores the process ready to execute in the main memory. So it whenever there is a queue, you have suppose P1, P2 and P3. 3 processes are in the job queue, and P3 does not want to execute now, and these 2 are ready, then these can be moved to the ready queue. Okay, so that P1 will be executed first and P2 will be executed next after the completion of P1. So all such things we'll be discussing in the process management. Then device queue contains a process waiting for an IO device. Suppose if this required, P1 required some input to be given. So it will wait for the user to give some IO operation, to perform some IO operation. Thereby it will complete its execution. So there's a device queue. So to process any data, you need to know what are the scheduling algorithms and also what are the different types of queues that are available, how to manage them. Okay. Then coming to the next one, memory management. As the name indicates, we are managing a memory here. Memory is nothing but where you have a free space to store any sort of data or the files. So it's a crucial function of the operating system, handling the memory allocation and process movement between the disk and the primary memory. So there may be a primary memory, secondary memory, virtual memory, logical memory. So what are the different types of memories you have, and how to load from these memories to your primary memory so that it can perform some task. Okay, so this secondary memory is something like disks that you are going to use, like CDs or pen drives using USB port, and different external resources that you are going to connect it to your processor so that it provides a secondary storage devices. We call them as a secondary storage device. Whenever you wanted to perform some task or the process to be executed from the secondary, you have to move that to the primary memory, then you can execute. That's a primary memory, is a main memory where we are talking about. So activities that are performed by memory management. So you have to allocate the memory, that is a memory allocation. OS assigns the memory to process using different algorithms. So various algorithms here we will be using a linked list, hash functions, or the something like that. So where we have to allocate, and what are the different types of, we have different types: best fit, first fit, or the worst fit. And we'll deeply discussing about what are they in the memory management, which is in the third unit. So allocate the smallest available block that fits the process. Suppose if you have a memory, say main memory, there's a P1 which is allocated, P2 is allocated. Now for P3 to allocate something like you want 5 MB of space. So you have here two spaces where this can allocate 10 MB and where this can allocate a 15 MB. Now if you wanted to put this data into your main memory, where you store this 5 MB of P3. So if I take this best fit, it allocates the smallest available block. So what is the smallest available? One is 15, the other is 10. So smallest is 10. So I allocate this 5 GB here. So 5 MB will be allocated, remaining 5 MB will be freed. So that freed space, this 15 MB and this 5 MB, again it should be managed by the free space management or storage management. So that's about the best fit. And then coming to the first fit, allocates the first available block where that is large enough, because if you have a 15 MB and if you have 10 MB of data and you have a P2 and P1 process which are allocated, if you wanted to allocate this P3 here, then it will obviously allocate in the 15 MB if it is the first fit. This is the first hole that we could see in the main memory. And the worst fit allocates the largest available block to minimize the fragmentation. So here something is missing. This is a fragmentation, where it is allocating the largest available block to minimize fragments. Means suppose if you have a suppose if I told you 5 MB here and 5 MB is left here, and this is where 3 MB is being used and you have 12 MB. So where these are called as a fragment, the remaining space that is left here is nothing but a fragment. So whichever the larger available block is there, that is allocated, that is called a worst fit. Okay, this is about the best fit, first fit and the worst fit to manage the memory. And memory tracking, it's keep track of, OS will keep track of the memory, which sections are in use and which are free, so that you will be knowing what is the free space that is available, what is the space that is already allocated and occupied. So deallocation, where you allocate and you can remove that processes from there, so that by using different techniques like swapping and all. Therefore you can deallocate the memory, where process terminates and a new process can go and store there. Okay, so that's about the memory management. And device management, it manages, OS manages various IO devices like mouse, keyboard, disk drive, USB, flash drives, or CDs, floppy disks, etc. Okay, what are their external sources? Okay, device drivers are used to communicate specific hardware devices, obviously, and device controller acts as interface between the device and the device drivers. So there should be something which has to control the drivers, so that if the drivers are not installed, it should stop performing the operations by, it will automatically stop performing the operations by using the device. So who is doing that? That is by the device controller. So user application access IO devices through device drivers which contain a device specific code. So user applications, they can access the device drivers. So when the device drivers have been installed, that means some code is running at the background, so which contain a device specific code. That's why we are calling it as a device specific code, not something like a programming code which you are writing for the different process and different scheduling algorithms, etc. And finally, we have a file management. So once you have a memory, once you have different process for execution in the queue, and once you have all the resources that have been established without any intervention, then we have to manage the files easily. It stores and manages the data. Okay. And storing can be of different formats like .doc, .exe, .pdf, dot something like dot class file, something, whatever. Okay, all these comes under the different file formats. Okay, and there are also different types of files which we can talk in the file management topic. Then all files are mapped onto the physical devices then to ensure the data safety during the failure. So physical device, you have to store the data. And file access method, sequential access, direct access, and relative indirect access is also there. So we call it direct access or relative access, sequential access, and data where data is read and written in the sequential manner. Here directly random access is taken, is implemented so that you can read it randomly from that. For reading and writing operations can be performed directly on the file itself wherever it is required. A sequential, one after the other, you have to go, you have to search it, you have to retrieve it, load it, then execute it. So records are accessed one after another because it is in the sequential manner used in file systems like text editors and compilers. That is about the sequential access. This deeply we again will discuss in the file management concept, which we are going to discuss in the 5th unit. This about the direct access, again, which we will be discussing again in the 5th unit very deeply with the help of some examples. So communication, finally communication, whenever if you wanted to communicate, say mobile phones. So today everyone is using a WhatsApp communication. So if you take the example of WhatsApp, how your communication is being happening. So the data is being exchanging between the processes, that is one user is exchanging the data between other users. There's a process that is happening, that is the data exchange. And inter-process communication, inter is remote. Okay, inter means what? Remotely you can data can be exchanged. So process communication, so what are the different mechanisms is, one mechanism is pipe, second is a message passing, and third one is a shared memory. So when you have pipe are again two different types. One is a named pipe and the other one is a unnamed pipe, that we call it as a FIFO. Named pipes and FIFO. Okay, so where these two are different types, where it provides synchronous and asynchronous types of data. It is something like connecting a tap to the pipe to the water tap, so that the water, when you are opening the tap, the water flows from one end and it retrieves, it is going out from the other end. So the read operation is performed from one end, or write operation is performed from one end, and the read operation is performed from the other end. So only one-way communication will be happening, that is named pipe, and unnamed pipe or something like FIFOs, where you communication can be happen in the both the ways, two ways. This is a unidirectional data flow. Message passing, process send and receive messages, say WhatsApp. That's a one-way communication. There may be a one-way, one to many, or many to many, or many to one. There are different types of communications. If you take a general one-to-one contact, then we call it as a message passing. You are passing just a message. A general text messages is also one example. Emailing is one example, where you are sharing to only particular mail. Okay. Suppose if you have a group of contacts together, where you maintaining a group where you have number of contacts in that group, then you can share the data in that group. So that is what shared memory. Multiple process access a common memory space. The best example is what we create a groups in the WhatsApp. So where everyone can send some sort of text so that all other remaining members can read it, can share the information. So suppose a network communication between different systems. So you need to have a network communication because we are doing a communication remotely. So you need the internet or the network to provide a communication. So this again deeply we can discuss further. Finally, we have to know what is the security, what is the difference between the protection and security, and how the security can be maintained. So protects the data system resources from unauthorized access. Suppose if you have your mail ID, you're giving your username and the password. Okay. If you're giving a wrong password, can you get login into that? No. That means you're not authorized. You're giving a wrong password. That is one example where we are providing the security. And today banking applications or any other applications, if you take any other websites, if you wanted to register and all, we are getting OTP. So OTP is becoming a trend where everyone is using OTPs for providing the security. Okay, and it implements user authentication like biometrics, face IDs, passwords, etc., security questions. Okay, when the data is getting leaked and you have some doubt of how whether this password is protected or it has been not changed for the longer period of time, our Google will also ask us to change our password. So to set the password which is not common or which is not given in the last 5 times. Okay, so those are few ways where you're providing the security. And uses encryption to secure sensitive information. So the data, if you have a plain text, you will be converting that into the ciphertext. Okay, this process of converting a plain text to ciphertext, we are calling it as an encryption. This ciphertext, this plain text will be in the alphabetical same, whatever the original data you have, and the ciphertext is where it is converting into various codes, so that it will be, there are different again algorithms are there. Again, there's a different subject where we talk about the network security or information security. We can implement different algorithms so that we can convert the plain text into the ciphertext. That process we are calling it as an encryption in the process of cryptanalysis. Okay, then enforces access control with the permissions and user roles. Suppose if you have one file, okay, say p1.txt. Suppose if you have this, if you wanted to, some third party wanted to edit some text here. Okay, there is something, a message called say send 5k to me or send 5,000 to me. There's a third person who is adding 2 more zeros here. Then the text is getting changed. So this is, we calling it as a man in the middle attacks. So there are some passive and active attacks that are possible. So such things can be restricted using this access control where you are not giving a permission. See, sometimes whenever you are opening a Word document, okay, whenever you are opening a Word document, it will be open only in the read-only mode to provide the security. If the user wanted to edit something, it will not allow. Whenever you are changing this to read only to edit, enable editing, then only you are going to edit here something. Okay, so that is a basic level of security. If you upgraded versions of your Microsoft is providing, this is just an example I'm telling you. So such permissions, where read, write, execute permissions can be maintained for users, for groups, for others by doing some constraints, by giving some constraints, so that we are talking it as a permissions. These are the permissions and these are the user roles, where maybe the user, maybe the group, or maybe the others. Thank you all.